this module, you will learn about some of the important physical properties of liquids such as vapor pressure, surface tension and viscosity. Let us start with vapor pressure. When a liquid is partially filled in a closed evacuated container, the molecules of the liquid that possess above average kinetic energies overcome the intermolecular forces that hold them in the liquid and rise to the surface. These molecules start escaping from the surface of the liquid and reach into the vapor state. The process by which molecules of a liquid go into the vapor state from the surface of the liquid at any temperature below the boiling point of the liquid is called evaporation. As the molecules escape into the vapor state, they get confined to a limited space above the liquid and start moving randomly. During their motion, they collide with each other, with the walls of the container and with the surface of the liquid itself. When these molecules collide with the surface of the liquid, they are attracted back to the liquid. This process is called condensation. During the initial stages of evaporation, the rate of evaporation is higher as compared to the rate of condensation. After some time, as the rate of condensation increases, the number of molecules present in the vapor state starts decreasing. Gradually, a stage is reached when the rate of evaporation becomes equal to the rate of condensation. At this stage, there is no change in the level of the liquid in the vessel, and the system is said to be in dynamic equilibrium, where rate of condensation is equal to rate of evaporation. At this stage, the vapor pressure of the liquid is referred as equilibrium vapor pressure or saturated vapor pressure. Thus, vapor pressure may be defined as the pressure exerted by the vapor present above the liquid in equilibrium with its liquid at a given temperature. Since the formation of vapor depends on the temperature of the liquid, vapor pressure is also a function of temperature. Let us look at what happens when a liquid is heated in an open vessel. Initially, the liquid vaporizes only from the surface. On further increase in the temperature, vaporization occurs freely throughout the bulk of the liquid and vapor pressure rises. After some time, a stage is reached when the vapor pressure of the liquid becomes equal to the external pressure. This stage is called boiling, and the temperature at which boiling takes place is called the boiling point of that liquid. Hence, boiling point may be defined as the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure. Do you know why food cooks faster in a pressure cooker? The boiling point of a liquid varies with the pressure. An increase in the pressure over the surface of the liquid increases the boiling point. In the pressure cooker, by covering the vent with a weight, the pressure inside the vessel is increased above the atmospheric pressure. Due to this, the boiling point of water also increases, and hence the food cooks faster. At high altitudes, the atmospheric pressure is low, and hence the water boils at low temperatures at these places. Hence, people living at higher altitudes use pressure cookers to cook food. The sterilization of the surgical instruments in autoclaves also utilizes the same principle as used in the pressure cookers. If the external pressure is 1 atmosphere, the boiling temperature is called the normal boiling point, and if the external pressure is 1 bar, the boiling temperature is called the standard boiling point of the liquid. The standard boiling point of a liquid is slightly lower than the normal boiling point, as 1 bar pressure is slightly less than 1 atmosphere pressure. For example, the standard boiling point of water is 99.6 degrees Celsius or 372.6 Kelvin. And normal boiling point of water is 100 degrees Celsius or 373 Kelvin. The variations in the vapor pressure of various liquids with temperature are as shown here. From the graph, you can see that the vapor pressure of a liquid increases with an increase in its temperature. That is, at normal room temperature, 298 Kelvin or 25 degrees Celsius, liquids like carbon tetrachloride, ethyl alcohol and water have a low vapor pressure. These liquids with low vapor pressure have a high boiling point and do not readily evaporate at room temperature. At room temperature, as diethyl ether has high vapor pressure, it has a very low boiling point. Therefore, it evaporates readily at room temperature. Let's now discuss about surface tension. This property of liquids arises from the intermolecular forces of attraction. A molecule in the interior of a liquid experiences equal intermolecular forces of attraction from all sides. Therefore, a single molecule in the bulk of liquid does not experience any net force. However, the molecules on the surface experience a net downward attractive force towards the interior of the liquid due to the molecules below it. Thus, we see that there is a tendency on the part of the surface molecules to go into the bulk of the liquid. The liquid surface is therefore under tension and tends to contract to the smallest possible area in order to have the minimum number of molecules at the surface. The attractive forces have to be overcome in bringing the molecules from the bulk to increase the surface of the liquid. This requires expenditure of energy. The energy required to increase the surface area of the liquid by 1 unit is defined as the surface energy. The units of surface energy are joule per meter square. Surface tension may be defined as the force acting at per unit length perpendicular to the line drawn on the surface of liquid. It is denoted by gamma and is measured in kilogram per second squared. Its SI unit is Newton per meter. To avoid the instability caused by the surface tension and to remain at the lowest energy state, liquids naturally tend to have the minimum number of high-energy molecules on the surface. To minimize the surface area as much as possible, the molecules of liquids assume the shape of a sphere. This is why mercury forms spherical beads instead of spreading on a surface. For the same reason, sharp glass edges are heated to smooth them. On heating, the glass melts and the surface of the liquid tends to assume rounded shape at the edges. This makes the edges smooth. This is called the fire polishing of glass. Due to surface tension, a liquid rises or falls in the capillary tube as soon as the capillary touches the surface of the liquid. Liquids wet the things because they spread across their surfaces as thin films. The particles of soil at the bottom of a river remain separated but are pulled together when taken out. This is because of the reduction in the surface area of the thin film of water. The magnitude of the surface tension of a liquid is directly proportional to the attractive forces between the molecules. This implies that the larger the attractive force, the higher the surface tension of a liquid. Surface tension decreases with an increase in temperature. This is because at higher temperature, the kinetic energy of the molecules increases. This reduces the intermolecular attraction, resulting in a decrease in the surface tension. Let us now look at another important characteristic property of liquids: viscosity. We can observe that certain liquids flow faster than some other liquids. For example, water flows faster than honey. This is due to viscosity. Viscosity is a measure of resistance to flow in liquids, which arises due to the internal friction between the layers of the fluid as they slip past one another when the liquid flows. When a liquid flows over a fixed surface, the layer of molecules in immediate contact with the surface is stationary, while the upper layers move with different velocities. The velocity increases with the distance of the layers from the fixed layer. This implies that the uppermost layer of molecules has the greatest velocity. This type of flow, in which there is a clear gradation of velocity from one layer to another, is called laminar flow. As shown, for any layer in a laminar flow, the layer above it accelerates its flow, whereas the layer below it retards its flow. The velocity gradient is calculated as the difference in velocity between any two layers of the fluid, represented by du, divided by the distance between them, represented by dz. A force maintains the flow of layers, which is directly proportional to the area of contact of the layers and the velocity gradient. This implies that the force required for maintaining the flow of layers is a function of the velocity gradient and the area of the layers. In the equation shown, eta is the proportionality constant and is called the coefficient of viscosity. The coefficient of viscosity is defined as the tangential force per unit area required to maintain the unit difference of velocity between two layers unit distance apart. The SI unit for the viscosity coefficient is 1 Newton second per square meter, which is identical to 1 Pascal second. In the CGS system, the unit for the coefficient of viscosity is poise, named after the great scientist Jean-Louis Poiseuille. An increase in viscosity decreases the flow of a liquid. An example of a highly viscous liquid is the glass. Glass is so viscous that it would take years to move a few inches. The mobility of glass can be noticed by measuring the increased thickness of the window panes of old buildings at bottom of the window pane. An increase in temperature decreases the viscosity of liquids. At high temperatures, the molecules have high kinetic energy to overcome the intermolecular forces, thus allowing the liquid layers to pass over each other. You have now reached the end of this module. In this module, you learned that the process by which molecules of a liquid go into the vapor state from the surface of the liquid at any temperature below the boiling point of the liquid is called evaporation. Vapor pressure is defined as the pressure exerted by vapor in equilibrium with its liquid at a given temperature. The boiling point of a liquid depends upon the external pressure. The energy required to increase the surface area of the liquid by 1 unit is defined as the surface energy. The units of surface energy are joule per meter square. Surface tension may be defined as the force acting per unit length perpendicular to the line drawn on the surface of liquid. SI unit of surface tension is Newton per meter. Viscosity is a measure of resistance to flow in liquids, which arises due to the internal friction between its layers as it moves. The coefficient of viscosity is defined as the tangential force per unit area required to maintain the unit difference of velocity between two layers unit distance apart.